All right, good afternoon, everyone, and welcome to today's webinar on certification and standardization. This webinar is organized by ETIP Ocean, the European Technology and Innovation Platform. My name is Lotta Pirtima. I'm the project officer at Ocean Energy Europe who coordinates ETIP Ocean, and we are coordinated by OEE with the support of the University of Edinburgh, Wavec Offshore Renewables, and Technalia. So just some housekeeping rules before we start with the presentations. We will have a short Q&A session after each presentation and also at the end of the webinar. And you can type your questions in the question box on the right-hand side of your screen. We'll keep you all muted during the webinar, but you can write your questions in the box. The webinar recording and the slides, as always, will be on our website, etipocean.eu. So today's webinar topic is standardization and certification that is becoming more and more crucial in developing a product that's attractive to investors. But what are all the benefits and what are the risks? You will hear that today from our experts who will share their experiences and learnings. Our speakers today are a wide range of, from different backgrounds. We have a developer, a certifier, and a technical expert today. But before I introduce the first speaker, I would like to ask your opinion with a couple of polls. So this way our speakers can also address some of the points that come up in the poll results. So I'm just launching the first poll now. So now you should be able to see the poll on the right-hand side of your screen again, and choose. Yeah, I can see results coming in. Okay, great. So that is working. So this is a multiple answer, so you can choose as many options that you want. The poll question, sorry, I didn't read that aloud, is what is your main perception of the role of certification and standards? So you have 5 different options there, and as I said, you can choose multiple answers. I give you a little bit more time to answer the question. Great, I am closing the poll soon. Now I can still see answers coming in. I'm leaving it open for a little while. We have a 75% answer rate. This is perfect. This is an anonymous poll, so don't worry. Okay, I'm closing the poll now, so we can see the results. Just a second. Okay. So you should be able to see the poll results on your screen now. So the top answers were that certification and standards reduces risks. That was clearly the winner. The second one, I think, is leads to less design mistakes. But yeah, reducing risk was the clear winner. Let's go to our second poll now. Opening the second poll. So the question is, what is your perception of the drawbacks of using standards and certification, if any? And here you can choose multiple options as well. Okay, I'm closing the poll now. So you have a few more seconds to answer. There we go. I'm showing the results now. And it seems that the biggest drawback is that it's too costly for the current state of the sector, and inhibits innovation is the second biggest drawback. Great. Okay, so with that, we will start with the first presentation. I would like to give the floor to Christopher Ridgewell. He's the CEO of a Finnish wave energy developer, AW Energy, and they have an interesting story to share with us. Now, Christopher, you should be able to share your screen. Perfect. Now just remember to unmute yourself, and we're good to go. We can't hear you. You should be able to find the unmute button at the bottom of your screen. It's
okay. There we go. I found it.
Perfect. Okay, go ahead.
It was above my screen, actually.
Oh, okay. Some difference, yeah.
Yeah, no. Thank you, Lotta, as said. And this is a tough subject to tackle in 10 minutes because it covers really the last several years of our company's history, and certification has been really a core part of what we've been doing. But I'll do my best. So I'm going to be talking about the certification of this device. This is our first of a kind device that's currently deployed in Portugal. So I'm going to talk about several subjects here, but I'd like to start with why certified technology. So for us, certifying technology is really about our customers' need and our customers' profitability. You know, this is just an example here. If we take a project that's got a capex of say 50 million euros with a 5% return, and we have a debt equity split of 50-50, then we've got a return of equity of about 7%. If we increase that to 80-20, so 20% equity, 80% debt, that return on equity increases to 13%. So the more debt you have in a project, the higher the return is for the owner operator. But the critical issue is that for a project to hold debt, there needs to be a high confidence in the balance sheet. You need to know that your equipment, your assets are returning cash on a regular basis. And for that, the banks usually ask for business interruption insurance. And to receive business interruption insurance, you require third-party certification. So for us, certification enables project debt, which enables a higher return for our customers. It's pure and simple. It's about profitability of projects. I mean, why did we seek certification at the beginning? Well, it was a customer requirement of a project that we're working on. It gives us transparency. So if you imagine the technology roadmap as you work with new advanced technology, it's a bit like climbing these mountains. So we need to have transparency for the shareholders, so people know where we are on that climb. You know, which base camp have we reached and how many more meters do we have to climb? It gives us a structure for our process. You know, with innovative technologies, usually small companies and innovative teams. But to receive certification, you really need a structured process and you need repeatability. You need to have a pedigree for every design decision you made, pedigree back to codes and standards or pedigree back to tests. So this was very important for us, is also the repeatability in the design. So which standards are we using? Well, we're using the DNV standards, DNV OS 312, which is a certification of wave and tidal energy converters. And below that, we have a number of other standards. So very importantly is technology qualification. And then the other codes and standards such as offshore structures, manufacturing offshore structures, manufacturing concrete structures, etc., etc. So if I just start step one on our journey back in 2014, first step was to follow this process on technology qualification. So qualification is really about this table here, working out in the technology. So here we have a panel moving backwards and forwards, turning that motion into energy, into electricity that we send to the grid. So each component in this system has got individual, components, and we look at them, we assess them in terms of this table. Is it a new and novel piece of equipment, or is it a new and novel application area? If both of those are the case, we go into this red zone and we need to carry out some form of technology qualification. If it's in the green zone, we can use existing codes and standards. So a good example is our panel. So the panel is a little bit like a ship's rudder. You could say that it's on this table here. It's it's a new application area, but it's we have this backwards and forwards motion to some extent on a ship's rudder. But definitely it's a piece of equipment that requires technology qualification. So we carried out sea trials using our last device. We had the device and the panel covered in strain gauges. We used that to validate our numerical model. And with that validation of the numerical model, we could then determine our safety factors and our load cases. But actually, it was DNV GL that did this work for us. It was fairly straightforward to get straightforward. I'll say it was a big job, but it took us several months to collect all the sea states we required, but then took about a year to analyze and fully understand that. We had many hard disks full of data that required to be analyzed. Another area of this is the power takeoff unit. So in some ways it's like a steering gear unit, but in other ways it's quite different. So we built a full-scale test facility. We have this is a simplified illustration of the system. On one side, we capture that stochastic motion of the waves into cylinders and then capture that energy into hydraulic accumulators. And we can adjust the counterforce depending on the waves and get the maximum out from the waves. And then we have a separate subsystem that smooths that or provides smooth hydraulic flow and then smooth electricity to the grid. So in the bottom left, you can see the peakiness in the waves and the very smooth orange flow of the electricity going into the grid. So we were able to use this to test all the different components, test the modes of operation and the reliability of subsystems, which I'll touch on in a moment. Another key element of the work was working together with VTT in Finland, so the Technology Research Centre of Finland, to carry out. Actually, it was a full reliability, availability, and maintainability study on the equipment. The first step of this was an FMEA. So here we looked at each subsystem and the failure mode, that subsystem, the effects of the failure, the cause of the failure, how you detect that failure. That was very important. So what sensors you require, what means you have to detect that failure, and then what the current preventative measures and what improvement actions you can gain through this. So this was very useful. This helped us improve the measurement system, helped us improve our operational modes, and also our automation and control system. And several aspects of this resulted in hardware changes in the technology. So for example, our panel can move backwards and forwards without any connection to the PTO. We have a passive means of disconnecting. So in case of failure, we can disconnect and remove all those PTO load cases if needed. So this was very useful work. Another aspect of this study was a reliability simulation using ReliaSoft BlockSim. And this was done by VTT, and with this system, we could create the reliability block model, input the component reliability and any data from the test facility, gather the mean time to first failure, identify the weak points, improve that, and then repeat the simulation and go around. This was great, working hand in hand with this tool. Then once we were happy with the technology qualification work, we moved on to the design, procurement and manufacturing of the equipment. And this was a sort of an international project. We had equipment coming from all parts of the world. For example, these bearings came from Spain, if I remember correctly. We had castings that came from Turkey. Some bearing material came from Canada even. So certification also allows us to have confidence in the supply chain. So using those codes and standards, we're able to procure equipment in a way that the manufacturers could really understand what requirements we needed, and the surveyors could go and inspect that equipment. So we had confidence in the supply chain as well. The certification milestones are laid out here, from the initial power performance that we worked with Gareth Hassan back in 2014, to the inspection of the device by Lloyd Register after it was recovered, and then the gathering all that load case data and analysis by DNVGL, then the statements of feasibility, the technology qualification plan, the technology qualification activities, and then the certification of that. ISO 9001 was an important byproduct of this, because we had to build up our processes, as said, and that helped us to receive the certification through ISO 9001. Design appraisal, manufacturing, and eventually the prototype certificates at the end of last year. So it's a long process. I mean, from 2014 to 2019, we've been working with this. It's been the core to the activities. And this has really helped build confidence amongst our shareholders to show what we are doing, what we are spending their money on to get to this qualified technology. Other great benefits: the rigor of certification means that you really have to look at things very carefully, and for that you come up with new solutions. So we now have 82 patents, well, 63 patents, 19 pending, 82 overall, with 26 patent families. So we got quite a sort of comprehensive patent portfolio, thanks in part to the certification work. Next steps: we're working on the EU Horizon 2020 Mega Roller project. This is a view from 30 minutes ago of our test facility, a new megawatt sort of device. So this is our PTO being put together there. A lot of new innovations in this, and we'll go through the same reliability, ReliaSoft modeling as I described earlier. And then we continue with our operations in Portugal. So I hope I addressed the experience there, and hand back to you, Lotta.
Thank you very much, Chris. Yeah, it's very nice to see like these videos and pictures of devices actually being in the water. I mean, usually a lot of the devices are actually underwater, so you can't really get very good videos, but it's nice to see Wave Roller here on the screen. I have one question for you before we move on to the next presentation. So to which level of detail have you performed the original maturity assessment and the FMEA with VTT? How did you integrate design changes in the TQ/certification process?
Yeah, so it's a kind of an iteration, isn't it? The iterative process. So if we look at this process, you first assess you set your requirements, set your objectives, assess the technology, do your threat assessment. So this is even before the FMEA. We did a threat assessment, so a hazard on the technology, and then you define your qualification actions and then execute your plan. So it's a kind of iteration like this. So as we had design changes, we went through this process to iterate until we got to a sort of a level that we were comfortable with to move forwards, and the certifier was also comfortable with.
Thank you. Okay, we will certainly come back to you at a later stage. If you have other questions for Chris, don't hesitate to write them in the questions box, but we will now move on to our next speaker. So I'm happy to welcome Claudio Bittencourt Ferreira, who is the Business Development Director for Wave and Tidal Energy at DNV-GL. And so he will bring up some aspects from the point of view of a certifier. The floor is yours, Claudio.
Okay, thank you very much. I think that I was quite happy to have this presentation from Chris, because now I'm confident that I can jump some slides, because he already addressed some of the points that I would do it. So I will try not to repeat a lot myself in terms of what Chris has already mentioned. I will talk a little bit about DNV-GL. There are some news that and then talking about the standards and certification, what is it for? Talk a little bit about the risk-based certification, although Chris has already made a very good approach to that, the same with the elements of a risk-based certification. And then I will try to talk a little bit more in detail about communication with the stakeholders. So, well, about DNV, we're a global classification, certification, technical assurance, and advisory company. Our purpose is safeguard life, property, and the environment. And actually, the news is that from the beginning of this month, there was a reorganization within the company. And as a much larger commitment to renewables, there was a combination of the old business areas, oil and gas, and power renewables, into a new business areas, energy system. So these allow us to have like 4,000 energy experts that actually will be able to go across the supply chain. And as, for example, Chris has main reference, there is a lot of intertwined activities between oil and gas, wind, and of course marine renewables. So supply chain needs to work across different business areas. So it's a very large organization in terms of dedicated to, of course, oil and gas, but a lot of focus on renewables and accelerating the energy transition. The second news is from 1st of March, we become DNV again. So we came from DNV-GL after the merge, and now we're becoming DNV. So there will be a little bit of modification in terms of the logo. And this is a message saying, okay, it's a fully integrated company, and we are prepared to simplify the name. I must say, for many, many years, it was very difficult for me to say DNV-GL. It was much easier to just say DNV. Okay, standards and certification, not going too much into the same as Chris has already mentioned, but of course, it's just to clarify, standards provide the technical requirements, whereas certification is a service that is provided by an independent competent body to demonstrate compliance with the standards or the process that exists. So with this, and I think that the poll has identified, and I'm quite happy to see that the results in terms of, yes, it's a perception that this helps to reduce the risk and improve the design. And actually, that's what it's about. Standards, they also provide like a legal framework, define expectations between the parties, improve the supply chain, as you can see. And of course, as an interactive process, it consolidates and updating the knowledge of the industry into new standards and new procedures. So, of course, it's all about, again, what Chris has said, risk and reward. It defines like the attractive, the way, the capacity to attractive finance and what kind of finance you attract. And of course, the standards, they are instruments to control risk. As you control risks, you're reducing the fear of the insurance or the people putting money into the business. And just as a parallel, well-established industries tend to have standards with a high degree of prescriptive requirements as the technology has been matured and the level of innovation then is reduced or very slow introduction of innovation. So the more commodity and the more disseminated the industry, the more tended to have prescriptive requirements. However, marine renewables, although I'm doing this for almost 20 years, it's still early stage and require a different approach. And that was something that came with the use of the technology qualification process, provided this foundation to how to identify the risk, control, handling of uncertainties and novelty, as was explained before. And it's just to show how things can change. For tidal, we managed to create a technical requirement. So we have a standard for tidal, that is ST0164, that actually have technical requirements. But the process is still under the umbrella of the technology qualification process, as I will show. The advantage to have some well-established technical requirements suitable for the technology is the fact that it becomes a little bit easier to program, to plan yourself, because you know what is coming and you know where you need to go and what is the path to go. It's still like the technology qualification provided this, but the detail, having the technical requirements, helps a lot. And of course, we have in marine renewables the issue that the LCOE is very high, but it's not just about the LCOE is high, but it's also the future of what is happening, how we projected this into the future. And it's still like a lot of uncertainty in terms of the relevance of the CapEx data that has been obtained so far. The same thing about the operation generation, how the technology is evolving, because in the last 20 years, I have been seeing things moving around, and you can see that even, it's like a wave roller has passed through different stages and modification. Also, the supply chain needs to be adequate to deal with that. And of course, early stage financial costs are very high. And the perception, what is lingering behind is what is the market size that we are talking about. So all these impact on how you can perceive not just the LCOE now, but in the future, because there are some wide range that these things can move on. And of course, the low LCOE are normally associated with a good level of predictability in terms of performance, time, manufacturing, installation, maintenance. There is a competitive and large availability of a supply chain, more standards, detailed process, recommended practices. The markets are large. And of course, the consequence, the financial costs are low because the perception of the risk is also very low. So for innovative technologies, it's essential that the identification of risks are made and the establishment of mitigation actions are performed in such a way that it gives you a chance to succeed. Just briefly, in terms of, I have presented this before, it's like how the certification is associated with like the success criteria that at the end of the day has a strong connection with competitive LCOE. In the case, we start with CapEx and OpEx, and we aim to have a revenue, and all these, the balance between these will give you like the LCOE that we expect that will be successful and make you a successful financial enterprise. Of course, the CapEx OpEx is affected by capital costs, development costs, manufacturing, installation, operation, maintenance, and expected costs the monitoring, decommissioning, or refurbishment that probably is more appropriate for the renewable sector. On the revenue side, it's affected by the market and demand, energy policies, but also what kind of site you have and what kind of, how you can put your array to take the maximum benefit of that. Of course, energy policy is dictated by energy security, climate change, social benefits. It's something that's completely outside our role in terms of certification. However, the development course and this list here normally drives technical requirements like survivability, control of degradation, reliability and efficiency, installation limits, operational limits. So these are the targets that actually Chris has mentioned in the very early stages. So you define the basis that your technology can be successful. And then there is an interaction here between the costs that the technical requirements and the costs associated with them. So there is a little bit of moving up and down. And of course, it's also influence on the site and that you have and the type of array that you have. So the basis, the technical requirements given in terms of survivability, operational limits, actually, together with the site characterization and array, forms like the scope for certification. So that's the certification basis, or the qualification basis in the previous presentation. So that is a connection. So if we do have a strong, good technical requirements that reflect the expected costs, that expected business model, then the certification will be really helping you to achieve this success. In terms of have the same communication with the stakeholders, so we don't invent a new terminology. So we use very, very similar to what has happened in wind. So we're talking about like the prototype certificate, the type certificate, the project certificate. But what we have is this layer that is marked in blue as the technology qualification process that leads to a certification plan and the statement of feasibility. That's the first output from that. Very busy slide, but it's just to show this part that is shown here is similar to what Chris has shown, and I think that he explained very well. And just a little bit of a look into the risk side, where we have like 5 classes for probability, 5 classes for consequence, and these are associated to the risk matrix that is compatible with development in terms of the renewable sector. It's the same level of probability of failure that we are talking, so the risks are equivalent. So the marine renewables is not actually penalized whatsoever. And I must say, this process has been absorbed into the wind sector, because since we published our standard for the tidal in 2015, actually the elements of that standard has migrated into the floating standard, floating wind standard, and now is also incorporated into the fixed wind standard. So the risk is becoming ingrained into the process. The scope is, again, is like design basis. After you have the plan, you execute it. And of course, you need to go through all these stages: design basis, design, manufacturing, testing, transport, installation, commissioning, a final evaluation, and a follow-up during the in-service side, especially for prototype, where the prototype can lead you to confirm methodologies and other points that have been left out. So another point that it's important to highlight is transference of technology for the reasons of using existing supply chains that in the future they probably can adapt to marine renewables needs, but at the moment I think that is the other way around. We needed to know what the supply chain can do and what can be done, software and all this stuff. So there is a lot of technology that is already there and that doesn't need to be reinvented. So using office standards from other sectors like the wind, like even maritime, it actually is very advantageous. And I think that you can see some example of how standards from other industries can be applied in the tidal sector by just looking at our standard ST0164. This is what we do for tidal. We have, and it's very interesting that Chris has done something very similar as well. We have the service specification 0163 that defines the process for certification. Then we have a technical requirement, and then we do that. And then we are supported for all the other standards, including the IEC technical specifications. When we go to the wave, then we needed to go into the OSS 312, but then we need to dig deep into the standards and other elements to actually support the development of that. So the standards needs to be adapted, needs to be tailor-made for the requirements for the technology that we are looking to that. But that is part of the technology qualification process. So ultimately, it's like the deliverables that come is like a statement. That's how you communicate with your stakeholders. The statement feasibility, there is a statement and there is a report associated. So you can share that with any other stakeholders that deserve to have access to that information, facilitate the communication between developer and a potential buyer or investor. And then the traditional prototype type component certification, project certificate. So the project certificate is actually includes the citing of the type product into the location that is deployed, plus the elements of the project, like the infield cables, the hubs, and export cables, and so on. A final word is just to mention as well, in addition, the IEC Conformity Assessment Board is developing a certification scheme for marine renewables. The process also used, so this is a separate activity that is not related to our certification process, but that is an initiative in terms of international. The process also uses technology qualification process to perform certification. That's very reassuring. And there are already several technical specifications that are used at the moment that can be used and used by us. But in the IEC scheme is only IEC and ISO standards are accepted for certification, except if there is a very compelling case to use something else. And because of that, there are many gaps in the standard process to provide enough support to type and project certification. But I will leave this to actually Peter to talk about that. And that was the hook to the next one. Thank you.
Thank you very much, Claudia, for a very comprehensive presentation. I suggest that we move directly on to Peter. We're a bit late, delayed from our schedule. So our last speaker is Peter Schegrund, the Director of Met Support. He's also the co-convener of the before mentioned IEC RE working group on scope of certification. So please, Peter, you can start your presentation.
Yes, I found the unmute button as well. Thank you, everyone, for your interest in joining this session, and thanks for the two speakers before. This is all very complimentary. Encore is a project in which we are applying for the first time the whole suite of technical specifications developed on the IEC in 4 different pilot projects. So I'm going to explain how we do that and how the IEC suite of standards looks like. A slide about myself. Met Support has been working in the marine energy sector for over 20 years, working on the financing of projects, technology development and project development, and managing R&D projects, and increasingly involved in the development of certification on the IEC. So I developed a vertical axis turbine and worked with Blue Water on the deployment of a floating device in the Netherlands, and with Tocardo on the dam integrated turbines. So conformity assessment on the IEC RE, it's just been mentioned, but this is the definition. It's a third-party system, conformity assessment system, based on international standards and technical specifications prepared by the IEC for the equipment used in renewable energy. And it covers 3 domains: solar, wind, and marine energy. And basically, it demonstrates that equipment fulfills the requirements of the standards through testing and verification. So the IEC is based in Geneva and has different parts to it. On the left-hand side, you have the standards committee under the Standardization Management Board. And in there, in the gray area, you have project teams, maintenance teams, and working groups. And those are all experts from industry and academia and government that are contributing to development of those standards. And this is also a warm invitation to anyone who is interested in this to contact us in the ISC to see if they can get involved in one of those working groups. And then in the middle, you see the conformity assessment system. And there's a whole range of them, but the one that we're talking about relevant for marine energy is the IEC RE for renewable energy. And in there, there's special working groups covering wind, solar, and marine. So this is a worldwide system, and the advantages have already been mentioned by Christopher and by Claudio, so I will not go over that. But the idea is that the IEC regulates the system through accreditation of member organizations. So on the left-hand side, the accreditation body, in this case, the IEC, and provides accreditation for a certification body like DNV or Lloyd's Register or Bureau Veritas or Class NK in Japan, similar to an inspection body and similar to test laboratories. And those are the three parties that can create the type certification or project certification, ultimately for the applicant. So one of the unique features of an IEC system or an international system that goes beyond the very well developed suite of tools provided by, for example, DNV or Lloyd's Register is that it has a reciprocal acceptance between the test labs and certification bodies worldwide. So just a small example, let's assume that a wave energy technology developer in Germany goes through technology qualification with one of these certification bodies. And then they go for testing to EMEC in Scotland. And they will be issued a test report by the test lab EMEC. And then they will do a project in Japan where they're going to do the manufacturing and the final deployment. And they will hire maybe Class NK. So in this process, all the documentation and the entire process is reciprocally accepted between all the participating bodies. And this is very helpful because, as we all know, the process and the cost can be very long. And so all the documentation that you build up in these processes is actually being supported step by step by taking each time a chunk of your certification process in the country where you're active. So this is the suite of standards that are relevant. We're mainly talking about the TC 114 that is focusing on wave, tidal, rivers, and OTEC. And then there's also TC4, which can help for tidal barrage systems, low-ed hydro, and TC82, which is looking at solar and also developing one specifically for floating and offshore floating solar. And salinity gradient is not yet covered. So there's a suite of generic standards that you see all the way on the left-hand side that are applicable to all the different technologies. And then there are specific ones for wave, tidal, river, and OTEC, looking into performance assessment, resource assessment, and skill testing. This process has also been shown by Claudio in a slightly different way, but let's focus on the central part. It starts with an assessment or evaluation of the design basis, your specifications for the design. Then once you've made the design and you've got manufacturing drawings and engineering calculations, you do the design evaluation. You can have a route also to scope out different parts, for example, for the foundation. On the left-hand side, you have input of maybe an assessment that you've done prior on a specific component, leading to a component conformity assessment. Then you have the manufacturing evaluation and inspection, and then you have what we call generally type testing. The type testing is really the performance of the system, so the performance assessment of a wave or tidal energy device, typically done by a test laboratory, who issue then a test report. For example, acoustic measurements, or loads measurements. Loads measurements could be done in critical components or in a mooring system. And then there's a final evaluation, and all the documents together, the different conformity statements that are being issued for each step, can create a type certificate. And then beyond type certificate will be a project certificate if you consider the resource and the site as mentioned by Claudio. So how do we do that in the Encore project? In the Encore project, there's 4 pilots, and we go through all the steps on the left-hand side, the engineering steps that are going in every product development process. And we apply the different numbers for the relevant technologies. And at the end, we will deliver projects at TRL 5 or 6 in the relevant environment of a vertical axis turbine by Water to Energy, a river turbine developed by Eel Energy, a wave energy device, and offshore floating solar developed by Oceans of Energy. And all the learnings from the application of these standards will go into recommendations to the groups that work in the IEC to develop those standards. So many of the people that are in the consortium as partners or as observers are already closely involved in IEC, and they are experts in the different working groups. And so this is how we provide the feedback directly from the project into the IEC working groups in order to develop second editions and eventually a technical specification after 5 years or after multiple editions, they become standards. So we would like you to get involved in this process because it will help you to get access to market intelligence, to understand how your technology can qualify and meet the standards. It will help you to focus your innovation on the specific demands that are being asked as part of the process. It will also enable you to get access quicker to global export because you're using the common language. And will help you to get access to commercial funding and insurance as explained by the previous speakers. So I want to alert you to 2 things. One is that one of the partners in Encore is developing a dedicated training program that will be launched on the IEC Academy. We expect it will take about 2 months. So please visit the website for IEC and stay in touch if you want to learn more about this. And here's just a sneak preview of the learning process. There will be an introduction in all the terminology. Then we'll detail about what is certification, how can you use the technical specifications, and how does it become relevant for your technology. The other thing is that we've just launched a survey, and we'd love to hear how involved you already are in applying standards or certification as part of your development process, and what kind of needs you may have and what kind of priorities you have. So please visit the website iec.org and click on the green button to fill in the survey. It will help us tremendously. And that is my presentation. Thank you very much for your attention. Back to Lotte.
Thank you very much, Peter. Thank you. I think you can leave your slide for a while. I know that's okay. I will put the slides on the website, so everybody who wants to get the links directly, just go to etpocean.eu and events and this webinar, so you'll find the slides there and you can find the links that Peter mentioned. So while I let participants write their last questions before we wrap up, I would just like to ask one question to all of you. I was wondering, what do you see as the next step or requirement in terms of certification or standardization for ocean energy, either from the industry or from the governments and policymakers? I don't know who wants to take this first. Claudia, I see you speaking, but you are muted.
No, I was just offering Chris to have the opportunity to say.
Okay, Chris, you want to go first?
It's a really tough question, that, because so the design and deployment of technology is really costly, you know, and tough, and it takes time. And so on the one hand, you have this challenge. On the other hand, you need to sell technology to customers, you know, and you need to start selling. So we've got these two, you know, the time it takes to certify the technology, and then the requirement for a business to sell technology. And yeah, I believe that there is a role. I mean, wave energy, I believe, has a very important value to the grid. You know, that just by the fact that it produces electricity, you know, when solar doesn't, and when wind doesn't, you can have wave energy coming in, this out of phase nature, which we've also recognized is very important for hydrogen production as well. Yeah, we've done a lot to get there, but I reckon, you know, it's taken us several years, and other technologies are coming through, and it's of course going to take them several years to get to this level of certification. And is how much do we want this value, the value that wave energy brings? I think it's very important as we move to greater proportions of renewable energy, but in order to deploy a large amount of that, we need financing, and for that we need confidence, which we get through certification. So it's a bit of a roundabout answer to your question, but it's a tough question there.
Thank you. Claudia, go ahead, and then Peter.
Okay, now I just would like to add one thing. It's like when I mentioned and I showed this slide about the connection between certification and the success criteria that would be leading to a low level of you know, COE, I just would like to emphasize that it's still a big gap between, it's like, what is the business model and the success, you know, that's expected, because the business model will need to consider all the expenditure, the capex, the opex, and so on, and how much they can generate, and then needs to be profitable. So the COE needs to be competitive, and that is something that is, the certification can only enter into the output of the business case. So it's down to, like, for example, Chris, to just say, okay, if we have this technical requirement, if we have this level of reliability, if we have this level of survivability, if we have like this and that, I will reach the point. So the certification works on that premise. Of course, I think that is important that at the same time that Chris is providing like the confirmation that is achieving the target, there is a need to also show that the financial, the business side is actually strong, and this technical requirements will be sufficient for that. So that is a very important aspect. And I believe that, again, in terms of investment, in terms of progress, in terms of getting a slice in the market, it is important to know that the technology that is put forward will be, if it's not now, but will be competitive to actually have a market in the future. And that is something that has been discussed before in other forums in terms of discussions about technology performance level. It's always something that is quite important to see how you can demonstrate that you will achieve that particular LCOE that will make your business successful. That's important to say. The standards and let's say the certification, it's based on the premises that comes from the business model.
Maybe I can add, I see also the question, what kind of action would you like the European Commission to take to increase certification standardization? Well, my call to governments is to support the development and the application of certification in all demonstration projects for marine energy, and supporting means, of course, through incentives, good funding mechanisms that allow the project and the technology developer to bear that cost easier, because it's all parties are still learning. It is an extra task to do, demanding resources. So if that can be supported through all the programs, gain confidence for investors. And I think also for the European Commission, it is an advantage to create a service market for testing and certifying technologies here in Europe.
Thank you, Peter, and answering to that question as well. We have a couple more minutes, so I quickly take one question that I have here to Chris. So if you could do the process again, what would you do differently? Where have you saved time and costs?
Okay, just unmute. I would say it's very difficult to separate the certification process from the technology development process. You know, I think we would have done whether we had certification or not, we would have had to do all the same things. We would have to do the hazards, the FAMICA. We would have done all that. We would have done the reliability modeling. We would have built the test facility. We would have done the full-scale testing, done the tank testing and the at-sea testing. We've done it all anyway. So the certification kind of bolted onto that quite nicely. But there's nothing I would say in the certification that I would do again. It's obviously this whole process has taken us longer than we initially had anticipated. So, but that's not due to the certification, it's due to other reasons, I think, not so much the certification process. So I can't think of any specific thing that I would have, you know, thought we would change. No, not now. I'm sure if I think about it very hard, maybe I can think about it, but I can't think of anything at the moment.
So you went well the first time. That's great.
Yeah, but that's just because it's part of, you know, the certification wasn't such a, you know, overwhelming thing. It wasn't the driver that we did all this work. It was the driver to do all this work that is, we wanted to have a good pedigree for our equipment, you know, a good confidence that it would work. You know, we could go to the market with confidence really and replicate what's been done in other industries like oil and gas and how they got to the market. So yeah, and then certification just helped us to demonstrate that we've done that. That's all.
Thank you. If Claudia and Peter, you have any closing remarks, I'd let you take the floor. If you have any final thoughts.
Well, I see one of the questions. Is there anything happening in South America? From Jacinto, who's calling in from Ecuador. Well, there's actually one in the call, and that is Claudio, who is dialing in from Brazil. So that's the first point of contact to talk about marine energy. But the university in Colombia and university in Costa Rica and also in Mexico, they are really working on developing pilot projects for wave and tidal and also OTEC. So there's things happening in Latin America, very interesting. Claudio?
Yes, there are some things. At least I'm more for the Brazil part. You know, it's like there is a little bit of a movement in terms of the wave, especially towards the south of the country. And I know there are developers in Chile, you know, it's like that they have been trying to push into that. The difficulty, I think, that is still like the countries, they don't have any support for that activity. So it's very difficult to carve a space to get the sufficient support because there is nothing happening in this area in terms of specific. I think that Chile has some support on that, but it's very, very difficult. So I think that's what I would say. But yeah, there are some work happening also in Mexico, and I believe it in Costa Rica as well.
Yeah.
Okay.
Thank you. I would say that we will wrap up here. We are a bit over time already, but I would like to thank all of our speakers today and of course all the participants. And as I've said, the recording will be on our website egyptocean.eu. So I wish you all a very nice evening and see you in our next webinar. Bye.
Thank you.
Thank you. Bye.
Bye. Bye.
Thank you.